Picture this. You are staring at a dense React dashboard, cards everywhere, icons, charts, sidebars. You just want to change one word on one button or tighten the spacing on one little row of icons. You ask your AI assistant for help, and then you wait while it churns through thousands of tokens, scanning your whole repo just to find that one component. Now, imagine instead you hold Command or Control plus C. Click the exact element on the live page, paste a blob into your AI chat, and the change lands perfectly on the first try. That is the promise of React Grab, a tiny tool claiming up to a 55% speed boost for AI coding tasks by giving models perfect context instantly. But here is the twist. It gets that power by tunneling straight into React's private internals, impersonating dev tools, and reading the entire fiber tree of your app. So you are not just getting a productivity boost, you are also inviting a very privileged piece of code into your development environment. In the next few minutes, we are going to unpack how this works, why it feels like a cheat code, and why some security-minded teams are seriously nervous about it. To understand why React Grab even exists, you have to see the hidden bottleneck in AI coding tools today. When you tell an assistant, change the text from count to counter, it cannot see your screen. It only sees text, so it indexes your project, searches every JavaScript and TypeScript file for the word count, then reparses the likely matches back into its context window. That search, guess, verify loop quietly burns thousands of tokens in multiple network hops, even for a trivial change. Benchmarks from BetterStack show a single tiny text change costing around 2,600 input tokens and 1,800 output tokens. That is nearly 4,400 tokens just to fix one word. On a toy app, you barely notice, but on a production React codebase with dozens of routes and hundreds of components, this tax explodes. Every vague request, like tighten spacing between these icons, forces the model to reconstruct your layout from file names and JSX structure instead of from the actual UI you are looking at. Here is where React Grab feels almost like a superpower. Instead of describing a button in prose or pasting half your repo into Claude or Cursor, you hold Command or Control plus C, click directly on the live element in your running app, and React Grab overlays the screen. Behind the scenes, it grabs the React fiber data for that element and copies a tightly formatted blob of metadata to your clipboard. When you paste that into your AI prompt, the model gets a cheat sheet, component hierarchy, file path, and a compact HTML preview, all in a structure it can parse deterministically. The impact is simple but huge. Instead of scanning hundreds of files to guess where submit order lives, the model jumps straight to component/checkout/submitbutton.tsx or whatever your real path is. Aiden Yeeb AI, the creator behind Million.js and React Scan, reports up to a 55% speed increase on dense layouts like the Shad C N dashboard when using React Grab versus traditional search the repo workflows. In a minute, we will dig into how it actually pulls this off under the hood, but first, you need to see why this matters most on complex UI, not just toy counters. Take the Shad C N dashboard example. It is a dense forest of cards, charts, sidebars, and repeated icon rows. Try telling an AI, reduce spacing between the notification icons next to the avatar in the top nav bar, but not the sidebar icons. You might have nav, navbar, navitem, sidebar navitem, and header actions components all sharing similar props and names. The model has to scan dozens of files and hope your naming stayed consistent through refactors. With React Grab, you skip the guessing entirely. You hit Command or Control plus C, click the exact row of icons you care about, and your clipboard fills with LLM-ready metadata. It includes the nearest React component name, the precise file path, often even the line number, plus a tiny HTML-style preview of what you clicked. So when you say tighten spacing between these icons by 4 pixels, the model targets one component, not every icon group with a similar name. This precision does not just feel nicer, it actually saves real money. Fewer false positive files means fewer tokens, fewer retries, and fewer wrong component edits. On large teams paying per million tokens, those tiny savings stack across dozens of dashboards and marketing pages. And that is before you count the human cost of waiting for slow suggestions or manually cleaning up messy AI edits. So how does React Grab actually do this? Under the surface, it leans on a tiny but audacious library called Bippy. Instead of scraping the DOM or parsing your source files, Bippy pretends to be React DevTools. It hooks into the same special global that DevTools uses, and once it is attached, it gets read access to the entire React fiber tree, the internal representation of every component, prop, and hook in your app. Fiber is not a public API. It is an implementation detail that powers concurrent rendering and features like suspense, and it can change between React versions without warning. But by tapping straight into Fiber, Bippy sees what React sees: the live, in-memory component graph, not just a static HTML snapshot. When you click a DOM node, React Grab uses Bippy to walk up the fiber tree from that host element to the nearest function or class component that owns it. That is how it can say not just this span here, but this span inside dashboard sidebar in sidebar.tsx. Once it finds that component, React Grab assembles a compact metadata bundle. You get the component name, file path, sometimes line and column numbers, a pruned hierarchy around the target, and a tiny JSX-style preview. All of this is wrapped in a Markdown and XML style block that large language models can parse deterministically. Paste that into Claude, Cursor, or any AI assistant, and the model can jump straight to the right file instead of playing detective over a noisy list of search hits. But here is the elephant in the room. Any library that can read your entire fiber tree and infer your file map is a very juicy target if it ever gets compromised. Bippy's access level is extreme. It can traverse component hierarchies, inspect props and state, and see how your app is wired together. In a modern React project with feature flags, experimental admin routes, and the occasional hard-coded test token, a malicious version of Bippy could do real damage. Think about a supply chain attack. If someone slipped bad code into a popular Bippy release, they could run arbitrary JavaScript in your dev session, scrape environment variables, or quietly log every component you click for AI help. That is not sci-fi. We have already seen similar attacks play out in the NPM ecosystem over the past few years. That is why Aiden Ebe AI's docs scream: development only, audit the code, never ship this to production. The good news is that React Grab and Bippy are open source and MIT licensed. You can audit the code, pin a specific commit, or even fork and self-host your own version to avoid surprise updates. But open source is not a magic shield. Most teams will never deeply review a tool that touches React internals, and many will just npm install whatever version the docs mention. If you adopt React Grab, you should lock it to dev only, vendor or fork Bippy, and treat every upgrade like a security event, not a casual bump. You might be wondering, with tools like Cursor's Instant grep and Cognition Speed grep, do we even need this kind of precision context hack? Those tools blast through your repo in milliseconds, shrinking the where's this code step to almost zero. They're like Control plus F on performance enhancers. But even when search is instant, the model still has to interpret a bag of hits, burn tokens reading them, and guess which snippet actually backs the element on your screen. React Grab attacks a different layer. It does not search faster, it skips searching entirely for the elements you can click. When you capture a component, the model gets one authoritative pointer with its props, nearest parent, HTML preview, and exact file and line. That is why Aiden's benchmarks on the Shad C N dashboard show edits completing up to 55% faster and with far fewer tokens. Used together, you can explore a new codebase with instant grep, then lock in precise UI changes with React Grab's element level metadata. So where does this leave you as a React developer? On one hand, React Grab turns Command plus C into a context laser for your AI tools, making them feel dramatically less dumb and more like true collaborators. On the other hand, it is powered by a deliberate hack into React's private architecture, which means you are accepting a real security trade-off in exchange for speed. The decision is not just technical, it is also about your team's risk tolerance and your appetite for bleeding-edge tooling. If you are curious to try it, the React Grab docs walk through setup for frameworks like Next.js and Vite, and the GitHub repo shows exactly how Bippy impersonates dev tools. The smartest move is to experiment in a sandbox dev environment with no real secrets and see how much friction it removes from your day-to-day UI work. Watch how often your AI assistant hits the right component on the first try, and how your token usage shifts over a week. Those numbers will tell you if the speedup is worth the operational overhead. In the bigger picture, React Grab is a glimpse of where AI-powered UI development is heading. We are moving from vague text-only prompts toward tools that can see what you see and hand model structured, ground truth context. Whether it is through official browser integrations, framework-level introspection, or hacks like Bippy, the future of coding assistance is about collapsing the gap between your screen and the model's mental picture. The real question is how we get there safely without opening up new attack surfaces we are not ready to defend. So, is React Grab a brilliant booster or a reckless risk? In reality, it is both a sharp tool that can slash through the AI coding bottleneck and a reminder that deep framework hooks always come with strings attached. If you are willing to keep it strictly in development, audit the code, and treat updates carefully, it can make your AI assistant feel 55% smarter overnight. If that trade-off makes you uneasy, you might wait for more official, supported ways to give models precise UI context. I want to hear what you think. Would you plug a DevTools impersonator into your dev environment for a big productivity boost, or is that a hard no for your team? Drop your take in the comments, especially if you have tried React Grab or similar tools. And if you want more deep dives into cutting-edge AI coding workflows and the security trade-offs that come with them, hit subscribe so you do not miss the next breakdown.